Okay, we need to rationalize the denominator, meaning we want to get the roots out of the bottom. To do that, since we have a root plus just a normal number, or if we had a root minus a normal number, or vice versa, you would want to multiply by the conjugate. Multiply the bottom by the conjugate, multiply the top by the conjugate. Now, hopefully you remember that when you multiply conjugates together, and you're going to have to FOIL the top, FOIL the bottom. Remember, a root t times a root t is a t. Your root t times your negative 4. Your negative 4 times your root t. Your negative 4 times your negative 4. Similarly on the bottom, but the bottoms are conjugates. Remember, when you're multiplying conjugates together, that the inner terms and the outer terms really cancel each other out and disappear. So then we just have the top, which simplifies down to this because you have your like terms. Your inner and outer terms drop, leaving you with just a 1 or a t minus a 16. So you have no root left in the bottom, and that's what we were trying to get to. So taking a look at this problem here, we want to rationalize the numerator. So on the last problem, we multiplied by the conjugate of the bottom because we were trying to rationalize the denominator. Here we're trying to rationalize the numerator, so we'll multiply by the conjugate of the numerator, which is going to be just the same, but we're going to have a plus sign instead of our roots, in between our roots instead. So then you'd want to FOIL. This first ugly root times this first ugly root would be an ugly root all squared, but remember the square root of something squared cancels each other out, so it's just the ugly thing on the inside. Then once again they're conjugates, so your inner terms when you multiply these two and your outer terms when you multiply those two should drop out. When you do the outer terms, it's just the big root times the small root. Inner terms, it's the big root times the small root, but it's a subtraction sign. So you do see that yes, they're identical, and so yes, they will cancel out. Then you got to do the last ones. It's a positive root times a negative, so it's a negative. A root times something messy times a root times something messy would be a root of something messy squared, which would undo the root, so we just have this. And now I'm not going to do anything to the bottom. I'm going to just leave it like that. Once again, these cross out. The middle and two terms here cross out. So now let's get rid of our parentheses on the top by distributing through. Just keeping the bottom the same, not doing anything with that. Now all we're going to do is go ahead and collect our like terms on the top. And we just get a 2h because your 2x and your 2x drop, your 1 and your minus 1 drop. Now notice you have an h times the whole top and h times the whole bottom, so they really drop, cancel out. So all you're really left with is just a 2 on top, and then what we had for our conjugate on the bottom. Now, some of you will think this problem looks a little scary, and you might be intimidated by it. But let's just do a little bit of work on it to try to simplify. Notice in the very beginning here, we have this. We could eliminate that parenthesis there by putting the 2x in front, and we won't have to have that. And so that's all we're going to do there. Now notice here, we have a 1/2, and we have a 2. Notice that 1/2 times your 2, they'll cancel each other out. We also have our negative here times this stuff making it negative, which means you're going to be subtracting a negative, which makes it positive, so that's why we have a positive here. You notice we also have an x here at the end times your x squared here, which is an x cubed. We didn't do anything with this part here, so we'll just leave that. On the bottom, you have an exponent raised to an exponent, so you're going to want to multiply your exponents. While your 2 times your 1/2, they cancel each other out, so it really just leaves you your denominator like this. Now, if you had an a squared minus an a cubed and you were asked to factor, you would pull out your a squared. You would pull out the smaller exponent. Sorry about that. Well, we're going to do the same idea here. Here we have our common factor in the top. We're going to pull out the smaller exponent. The smaller exponent would be this right here, to the 1/2. We're not going to do anything to the bottom. So we are going to pull that out to the negative 1/2. Question is, what are we going to have left? Well, we know we're going to still have this, the 2x we didn't do anything with. But we're really going to just have that left to the first power plus your x cubed, because that right there was pulled out. Now, you might be wondering, why is it just this to the first power? Well, remember, if you did want to distribute this whole thing here through, you'd multiply it through to this here, and you'd have to add your exponents. Well, negative 1/2 plus your 1 gives you your positive 1/2. So that's why it's to the first power. Well, let's go ahead and take a look and simplify what's inside the square brackets here. Distributing that through, plus our x cubed. This is a negative exponent, so I'm going to move that down to the bottom. Now on the top we have some like terms of some x cubes, so they're going to combine together. The bottom we have a 1 minus an x squared to a power times a 1 minus an x squared to a power, so all we have to do is add our exponents, and then we get this. And this does look a lot better than what we initially started out with.